In this video, we're going to talk about right triangle trigonometry. Let's review from geometry. Let theta be an acute angle. What is an acute angle? It's an angle that is between 0 and 90. Angle that is greater than 0 and less than 90. In a right triangle, what is a right triangle? It's a triangle that has a 90-degree angle. And the abbreviations opposite, adjacent, hypotenuse refer to the length of the side opposite theta, the length of side adjacent to theta, and the length of the hypotenuse, respectively. So it is important you see where the theta is located. The theta represents a measure of an acute angle. So anything that is opposite of theta, we're going to call it OPP. And theta, the side that is next to a theta, we're going to call it adjacent, which is represented by ADJ. And hypotenuse is always the opposite of 90 degree. Okay, again, hypotenuse is always opposite of the 90 degree. So if the theta was this angle right here, then this side right here will be the opposite, and this side will be adjacent. So it is very important that you locate the theta, and with respect to theta, you need to see which one is adjacent, opposite, and the hypotenuse is always opposite of 90, or the right angle. Then the sixth trigonometric functions of theta are defined as follows. Sine theta is opposite over hypotenuse, and cosine theta is adjacent over hypotenuse, and tangent theta is opposite over adjacent. You probably are used to these three from geometry, SOHCAHTOA. Now, cosecant theta is hypotenuse over opposite, which is the reciprocal of sine theta. Notice, sine theta was opposite over hypotenuse, but cosecant theta is hypotenuse over opposite. What about secant theta? Secant theta is hypotenuse over adjacent, which is the reciprocal of cosine theta. And cotangent theta is adjacent over opposite, which is the reciprocal of tangent theta. Let's take a look at this example. They want you to find the exact values of the 6 trigonometric functions of theta. So we have a right triangle, and here's a theta right here. So what is opposite of theta? Opposite of theta is 5. What about adjacent? Adjacent is going to be 12, because that is right next to the theta. And hypotenuse is the one that is opposite of 90 degree, which is going to be 13. So it might be better for you to find the opposite and hypotenuse first, because those are the easy ones to find. And one that is left over is going to be adjacent. Now, once you have these three information, it's easy to find 6 trig functions of theta. What is sine theta? Sine theta is opposite over hypotenuse, which is 5 over 13. What about cosine theta? It is adjacent over hypotenuse, which is 12 over 13. And tangent theta is opposite over adjacent, which is 5 over 12. Now what about cosecant theta? Cosecant theta is going to be hypotenuse over opposite, or the reciprocal of sine theta. And secant theta is going to be hypotenuse over adjacent, or the reciprocal of cosine theta. And finally, we need to find cotangent theta, which is going to be adjacent over opposite, or the reciprocal of tangent theta. So we have 6 trig functions. Now, this will be a good practice to find the exact values of 6 trig functions if the theta was located over here. Let's take a look at the next example. It says if cosine theta is 2 over 5, find the exact values of the 5 remaining trigonometric functions for the acute angle theta. So what's given is cosine theta is 2 over 5. And you know that cosine theta is adjacent over hypotenuse. So we know the adjacent is 2 and hypotenuse is 5. So let's draw a right triangle that represents this situation. So here's a right angle. Let's call this theta right here. And the hypotenuse is going to be 5. Adjacent is going to be 2. But we don't know what is opposite. Let's call this A. If we find the value of A, then we could find the remaining 5 trig functions. Well, this is a right triangle. So that means we could apply Pythagorean theorem. So 5 squared equals 2 squared plus A squared. So you get 25 equals 4 plus A squared. You get 21 equals A squared. And you get A equals positive, negative, radical 21. But you know that the length can only be positive, so A has to be radical 21. So we have the adjacent as 2, opposite as radical 21, and hypotenuse as 5. Since we have these 3 information, now we could find the remaining 5 values of trig functions. So sine theta is going to be opposite over hypotenuse, so radical 21 over 5. Cosine theta was given, it was 2 over 5. And tangent theta is opposite over adjacent, which is radical 21 over 2. Now, what is cosecant theta? Cosecant theta is the reciprocal of sine theta, which is 5 over radical 21. And you don't want to have a radical on the bottom, so multiply by radical 21. Top and bottom, you end up getting 5 radical 21 over 21. What about secant theta? Reciprocal of cosine theta, which is going to be 5 over 2. And cotangent theta is going to be the reciprocal of tangent theta, which is 2 over radical 21. Again, you don't want to have a radical on the bottom, so multiply top and bottom by radical 21. You end up getting 2 radical 21 over 21. Now let's talk about how to evaluate trig functions of an angle using graphing calculator. So what you need to do is you need to go to mode. And then you see radian and degree. Since we're going to use a degree, make sure you change your mode to a degree setting by using your cursor and press enter. So now you notice that degree is being highlighted. Now let's press second quit to go to the main screen. Let's say you want to evaluate cosine of 40, cosine of 40 degree. And you press enter. That is the cosine of 40. What about sine of, let's say, 30, sine of 30 degree? Press enter. And sine of 30 is 0.5. And notice you have only a sine, cosine, and tangent. What if you want to evaluate cosecant of 30? Well, cosecant of, you know that cosecant and sine, they're reciprocal. So if you want to evaluate cosecant of 30, what you got to do is you got to do 1 divided by sine of 30. That is going to be the same thing as cosecant of 30. This is how you use your graphing calculator to evaluate trig functions of a theta. Let's take a look at this example. It says find the value of x, round to the nearest 10 if necessary. So we have a right triangle over here. The theta is 42 degrees, and this value adjacent is x, and the hypotenuse is 18. So which trig function describes this situation so that we could find the value of x? Notice the adjacent is x, and we got hypotenuse. And you know that cosine theta is adjacent over hypotenuse. So, and the theta is 42. In order to solve for x, we need to multiply both sides by 18 to get 18 cosine of 42 degrees. And we need our help with the calculator to evaluate this. So using our calculator, now again, make sure your mode is in degrees because we're going to be using in degree. 18 times cosine of 42. Press enter, and you get 13.3766. We're going to round it to the nearest 10. So this is approximately 13.4. So x is approximately 13.4.